Hello, welcome to our tutorial. This is one of the final steps for FluoroMatch IM mobility software and definitely the most fun step. My name is Jeremy Comel, CEO of Innovative Omics and research faculty at Yale University. And today we're going to show how to upload your data into Power BI for validation and compound discovery. We'll also talk about the features of this visualizer platform. And in the next video tutorial after this, we will discuss how you can walk through the data set row by row and confirm all of your species, label them, and then bring them back in to have a final data set you can release online with your annotations for sharing with the community. So to start, first you need to go into FluoroMatch IM. So you'll have this FluoroMatch IM software, and you'll have a visualizer folder in it, and you'll open up the .pbix file that comes with it, the latest version, double click it, and it will open. You will need to install Power BI Desktop. It's a free Microsoft product. You can look at the description of the video to look at the download link. This will also contain the download link for the software itself for FluoroMatch IM, as well as a link for video tutorials that will go over all of these different plots. We'll talk about each plot briefly in this video, but if you want to understand what Kendrick mass defects is, if you want to understand what Kaufmann plots are, if you want to understand what an isotopic pattern is and how to use it to annotate, we have videos on all these, so please see the description so you can learn about the fundamentals. So to start, again, you go to Transform Data, see this little arrow under Transform Data, and you'll go to Data Source Settings. This is where you load in all your data. There's going to be 4 files at this point. We may upgrade the software so you don't need these files. That's ideal. But you'll right now need the 4 files from the template folder, and you'll need 5 files from your outputs. These outputs are going to be the same folder that had your inputs that you used to run the software. So for the template folder, if you go to Change Source, Browse, and then if you look at FluoroMatch IM, go to the Visualizer folder, and then go to the Templates folder, you'll see those folders. So you want to upload the same one that you're highlighted on. So if it's negraw MSMS, you'll want to upload negraw MSMS. Note that if you did use the PNML preprocessor and ran some DIA data that was deconvoluted and walked through our other video tutorial on how to do that super user workflow, you may have your own negraw MSMS, but generally we don't expect that. So this will be something you use as your template, but the 5 that you will have is the drift time EICs, the MS1s, the P formula MS1s, the retention time EICs, and your final feature table. So you'll have to change every single one of these. I'm not going to go through it, but you would get the idea. You would then navigate to your output, find drift times EICs, upload those, and then press OK. So I'm going to discard changes here, but normally you would select the apply changes. And it would slowly upload, and within 5 to 10 minutes you would now have your new data set. Now the data set begins with filters just on score. So it already has these preset filters, so if you want to see a feature and it's not showing up, make sure to deselect these filters. A and A minus are CCS matches. C plus are those that fall in series with A or A minus. And then there's also B and B plus, not shown here, but B plus is also a CCS match, but it's to a predicted library rather than an experimental or standard-based library. Now on the top you'll have filters. So you can filter by score as we just showed. So if we want to add D plus, which is series that don't have a CCS match but do form homologous series, you can add them here. If you have a specific feature, let's say you're looking at your table and you have a feature that you'd like to look at, you can select that here and it will pull up that individual feature. If you have a series you want to look at, you can do that as well. So let's look at one of these most abundant series. So the series looks interesting, so you can see it's series 2, and then we also have series 4 is another one that we might want to pull up. So you can pull up multiple series like this. So now we can see the series. So if we want to highlight one, highlight. If we want to highlight the other, we can highlight. You can see that there's something interesting happening here in drift time space with these two series being separated out. If you want to navigate series, you can right click this 3D plot and look. So MZ versus retention time, these seem to be pretty similar series. But if we look at drift time, they're separated. So interesting. Same MZ as well. So these could be an artifact in the IM mobility. Another thing you might want to notice in these series is that you can barely see the series 4. It's very small, so if you want to take off any of these variables or change them, you can. So you can change your axes. Here are the 3 axes to change, your color by. So we could color by, for example, score. Now we can see, okay, here's my high confidence score over here. If I scroll over it, usually you can see the labels. I'm not sure why it's not showing the label, but of what these compounds are. You can also look at the labels over here. So here would be the information on this compound and the structure. Now, again, as I was mentioning, let's say you want to see all of these species. If you click size by none and put your scaling up, now you can see all of the different species, and we can color again by series. So we noticed before that this green series was barely visible, as well as some of these other molecules that don't fall along the trend line. So these might be tailing or other artifacts. They didn't show up when we sized by. So this can be helpful as well if you want to not have the size by function. All right. So you can play around. There's a lot of options in this. I do want to mention, and I'll show it at the end, but there are a few options if you select that will freeze the software. Not our fault. We're mooching off this graph, so we didn't create it. For example, one is the facet by, so we'll show it at the end, but it will freeze your software if you try to undo it. Another thing that could be interesting, again, is you can choose any kind of column. So let's say there's a column that's not here. We can go into our data and pull in a column. So let's say like the equivalent carbon number. That could be an interesting column to add. That will automatically add to the tooltips. So now you can see equivalent carbon number, and you can also now plot it, assuming, yep. So let's say we want equivalent carbon numbers to drift time and MZ. We can now plot that and see those patterns. So put this back as retention time. So there's a lot of options. I won't go over all the options here, but I think you see that there's plenty of options. There's also a filter by abundance. So as we can see here. We have some major abundant ones and not, and so we can always cut off just to see those most abundant features. Now, you also have these other plots that can be easier to look at instead of having to navigate the 3 dimensions. If you want to look at the specific effects of 2 dimensions on each other, you can just look at all the side-by-side plots of retention time versus mass charge, drift time versus mass charge, and drift time versus retention time. Can be very helpful. You can already see some unique trends that you may not see otherwise, especially in the retention time versus MZ and drift time versus MZ. You can also see the EICs. Everything's cross-filterable, right? So if I look at this sulfonic acid, in retention time it seems to have a lot of unique isomers. I can pull it out here. So they all seem to collapse in drift time, except for 1. So there's only 2 that have differences in drift time. You can see that here. So let's say we can here now see these are the 2 that are separated out in drift time, and you can see all the isomers in retention time. You can also see that this data is highly saturated, too much abundance. This is chemical standards. Now there's a bunch of other plots. Again, we'll cover how to annotate those in other tutorials, but let's say I want to pull out our C8 species. There you can see the nice peaks. Let's filter by abundance to look at some of the most abundant ions, because we're going to want to look at formula prediction as well as isotopic patterns. All right. So here we go, C8 sulfonic acid. Now you can see, again, the EICs saturated. You can see the MS1 pattern over here. And you can see the labels, so M, M+1, and M+2, and you can see the different isotopes and their mass difference, in case you do have fine isotopic pattern. You also have your table, and you have your Kaufmann plot. Let's see if we get some... All right. So I wanted to find one that had a formula prediction as well. If you have a formula prediction, you'll see the isotopic pattern here. Here, the formula prediction is wrong, but that's where you would find it. And you can look at different possibilities as well here to see how they matched. Here we only have 5 formulas predicted. Because it's saturated, you have much stronger M+1 than you would expect, so not the best data for formula prediction. So you'd want to reduce your injection volumes. Let's look at all the data at once. Note that at times, you might get an error in this plot. Generally, there's not much you can do, but you can go to grid and scatter and then it will come back in most cases. Same thing I wanted to show you with the facet. This is another error that can come. So let's say we're faceting by series. So now each series has its own graph, and that's really cool because now you can see the trends much more clear. So if I pull in all the compounds, for the high level, you can see some of the most high level series over here as well. This was the issue I talked about though, is if you do use the facet and you try to unfacet, it freezes. So with that, I'm going to end this video tutorial. I hope this gave you a wonderful look at the visualizer.